Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve two of the solutions from mechanics, and these two solutions belong to paper 9709/45 for the session May June 25. We are going to start with the solution number 2. Let's see what the question number 2 says. It says a machine for driving a nail into a block of wood causes a hammerhead to drop vertically onto the top of the nail. The mass of the hammerhead is 1.5 kg and the mass of the nail is 0.005 kg. The hammerhead hits the nail with speed 32 meter per second and remains in contact with the nail after the impact. Calculate the speed with which the combined hammerhead and nail move immediately after the impact. Give your answer correct to 3 decimal places. So let's see the system. Yes, this is whole of the system. And first of all here, it carries only 2 marks, so it should be one of the simplest of all solutions. But picking up the concept is the major part of the solution. First of all, we should know which concept is applicable in this case. If we analyze the question, we will see that hammerhead is hitting the nail. That means this is collision between two objects. That's why we are going to apply the concept of the momentum, conservation of momentum. So conservation of momentum is mass of particle A or H. We can write hammerhead. Mass of hammerhead into initial velocity of hammerhead plus the other object is mass of nail into initial velocity of nail is equal to, that initial means just before hitting the nail, then mass of particle H, I mean hammerhead, into final velocity of H, and totally it is coalesces. So will after the collision, look at this, after the collision it is written remains in contact with the nail. So both of them have been coalesce. So we can write coalesce, okay, velocity of coalesce plus mass of nail into velocity of coalesce, that means after the collision. Then mass of particle H, I mean hammerhead, is 1.5 kg, 1.5 kg, and it was at rest initially. Sorry, not at rest, it was hitting at a speed of 32 meter per second, 32 meter per second. Then mass of the nail was 1.005 kg, 0.005 kg into the nail was at rest. Look at this. Mm, nail is definitely at rest. Calculate with the combined hammerhead and nail move immediately after the impact. The hammerhead hits the nail and remains this one. So initially hammerhead was at rest. That's why initial velocity before hitting or before collision, the velocity of nail was 0. Then hammerhead mass of hammerhead is 1.5 kg. So 1.5, and velocity of coalesce or combined object plus mass of nail is 0.005 into velocity of combined object. If we multiply 1.5 by 32, it is going to be 48, equal to, it is 0, then 1.5 plus 0.005, so this is going to 1.505 velocity of the combined object. Then velocity of coalesce or combined object is 48 over 1.505. Hence, velocity of the combined object is, if we divide 48 by 1.505, it is going to be 31.8937. So if we round it up to three significant figures, it is going to be 31.894. 894 is the velocity of the nail after collision. So that is our answer. Now let's move on to the next question, the immediate next question, I mean B. Let me write here answer. And B says, sorry, there is a constant resisting the motion of magnitude 25,000 Newton. Calculate the distance the nail is driven into the wood. So one thing is very sure here, that we will have to find the distance, and for distance simply we apply the concept of the Subert formula. And Subert formula, for any of the Subert formula, we'll have to know the acceleration of the object. So for acceleration we will have to apply the concept of the motion law of Newton. So as nail is being entered, it is downward force, so we will write the concept of the motion law of Newton is driving force minus resistance force is equal to mass into acceleration. Well, we are searching for acceleration because without acceleration we cannot apply the concept of distance. Well, so or driving force. We know that driving force is mg cosine, we can write sine 90 degree, because the hammerhead is hitting the nail vertically downward, minus resistance to motion is to be obtained. Okay, it is given, sorry, resistance to motion is 25,000, 25,000, and mass of both of the particles combinedly is 1.505 into acceleration. Okay, then our acceleration is going to be, okay, mass of both of the particles combinedly, it is 1.505 into acceleration due to gravity is 10 and sin 90 is 1, minus 2500 is equal to 1 point, we can write 1.505 equal to acceleration. So our acceleration is going to be, if we do this calculation using our calculator, let me do the calculation. Using our calculator, we get the acceleration is equal to negative, it must be negative, negative 16601, 16601 point 29568, 2929568 meter per 568 meter per second square. This is our acceleration. I have taken more digits than necessary so that we get more accurate answer. So they have told us to find distance, so we should not forget that distance is equal to v square is equal to u square plus 2as. Okay, so let us write our concept for finding, because another formula is s equal to ut plus half at square. That means time is to be known, as we don't know the value of t, so simply we are going to apply the formula of v square is equal to v square is equal to u square plus 2as. So v square is the final velocity of the object. It must be zero, because when the nail was hit by the hammerhead, finally they came to rest. That's why final velocity is zero. Initial velocity was 31.894 square. From the previous question, we can use this. Let us see. How much was it? 30. This is our initial velocity while it hit, then it is going to be 31.894, 31.894 square, plus as acceleration is negative, so it is going to be 2 into acceleration is 16601.2956 into s. Okay, into s, and s is equal to, we require s is equal to if we transpose this 31 to the other side, it is negative, so both of them are going to be positive. 31.894 square is equal to 2, sorry, not minus, there will be no negative symbol. 2 into 16601.295. Then let's use our calculator. Equal to, let us use our calculator. The calculator shows that 31.8 and 4 square divided by 2 into point 0306 meters. So this is what our final answer to the second part of the same question is. So it was very simple to find. In the first case, actually, you may get confused with uh, application of concept. Simply, you just think that there are two objects, one is hitting the other one, that's why it is collision. So we'll have to find the velocity before the collision and after the collision, for which we always apply the concept of the conservation of momentum. Then in the second case, they have told us to find distance or speed. Distance, for distance we apply the concept of the Schubert formula. For Schubert formula, any of the Schubert formulae, acceleration is to be known, and acceleration can be obtained from the concept of the motion law of Newton. Then we have obtained this as acceleration. This is our acceleration. Using this acceleration, we have got that the nail got 0.0306 meter into the wood after hitting by the hammerhead. Well, let's move back to question number 1. Question number 1 says, a box of mass 25 kg is pulled 12 meter up a rough plane inclined at an angle of 8 degree to the horizontal. The box moves up a line of greatest slope against a frictional force of 50 Newton. The force pulling the box is parallel to the line of greatest slope. The box starts from rest and has speed 2.4 meter per second at the end of the 12 meter. Find the work done by the pulling force. So here, first of all, we can easily pick up the concept. They have already written the concept is work done by the pulling force. So work energy equation is to be applied as they have suggested indirectly to apply. So, and in work energy equation, the components are initial and final velocity of height, I mean difference between the initial and final velocity of height, and initial and final value of height, and initial and final velocity of the particle. So let us see what is the scenario. The scenario is this. Okay, angle is 8 degree. It is 8 degree, and the particle was moving up, and it moved to 12 meters. So hypotenuse is 12, and this is our h, angle is 8 degrees. So our h is equal to what? H is equal to, we know, hypotenuse and sine 8 degrees. Sine 8 degree. Sine 8 degree. Well, we have already decided that we are going to apply the concept of the work energy equation. So work done by driving force minus work done by resistance force is equal to change in GPE plus change in KE. That means change of gravitational potential energy as well as change in kinetic energy. Well, so work done by driving force is to be obtained. So work done by driving force will remain as it is. And resistance force, work done by resistance force. So we know work done by resistance force is F into S. F is equal to what? Let us see the frictional force. That means external force in this case is 50, and the displacement it made is 12 meter. Okay, so it's 12 equal to change in GPE is mgh, plus kinetic energy is half of mv squared. Okay, work done by driving force is, remember, you may get confused with the resistance to motion. In resistance to motion, you may tell that why are we ignoring weight. Remember, in work energy equation, external force is not only external force is applied, calculated. No internal force is applicable, as there is no external force acting on this, so there should be no resistance to motion due to weight. Weight is not calculated in work energy equation. Okay, external force is only driving force, pulling force. Okay, and there is no other force acting on this. Well, so it is 600 equal to mass of the particle was 25 kg, box was 25 into acceleration due to gravity is 10, and height we have already found, height is 2 sine 8, 2, sorry, 12, not 2, it is 12 actually, 12. So 12 sine 8, 12 sine 8, that means initially the this was the horizontal line. Initially height was 0, then finally height was h, and h is equal to 12 sine 8 degree, plus if we use half mv square, so half plus half, mass of the box is 25, and initial velocity was, it is given here, 24 meter per second. If we see here, we will see that 2.4 meter per second. So 2.4 meter per second square, 2.4 square. So this is actually difference between the initial and final velocity. Initial velocity was 0 because it started from rest. That's why final velocity minus initial velocity is 2.4. Then let us do the calculation. Work done by driving force is equal to 60, plus it is going to be 250 into 12, that is 3000. 3000 sine 8, plus it is going to be 12.5, 12.5 into 2.4 square. Hence, our work done by driving force is going to be, let us use our calculator, 60 plus, not 60, it is actually 600. So 600 plus 3000 sine 8 plus 12.5 into 2.4 square is equal to, let us see the calculator, it is 1089.51. 1089 1089.52. If we round it up to three significant figures, it is going to be 1090 joule. So this is what the answer to the question number 1. So that's all about the both of the solutions. Let me show the solution to two parts of the solution number 2. This is what the solution number 2, whole of the solution, and for solution 1, this is whole of the solution. And thank you all for being with me, and may Allah bless us all with all beneficial knowledges.